Hello everybody, in this video we are going to be covering how to utilize TypeORM in your Node.js application. Now TypeORM is a great ORM for JavaScript and TypeScript. Now what is an ORM? Well, an ORM is an object relational mapper, and what it does is it really simplifies the way that we are going to be interacting with our database. Now TypeORM has support for multiple different databases, but typically when we use TypeORM, we are using some sort of SQL database like MySQL or Postgres. But TypeORM also has support for NoSQL databases like MongoDB. Now in this video, we are going to be utilizing Postgres as our database, and we're going to be using TypeORM to interact with our Postgres database, but the concepts that you learn here are going to be very similar to if you were using a MySQL database or even a MongoDB database. So don't worry if you have another database preference, but I had to pick one for this video, and I think Postgres is pretty much the standard nowadays. Everybody's using Postgres over these other databases. So that is what I'm going to be doing. Alright, so that is enough. If you want to read more about TypeORM, just go to the TypeORM.io, and they have some pretty good documentation, but I'm going to try to cover almost everything in this video. So what are we going to be doing in this video? Well, we're going to be designing a database, and what we want to ultimately do is create some sort of banking system. Let me explain. So over here, what I want to do is I want to store all of the clients that are utilizing a specific bank inside of our database. And then I also want to store all of their transactions. Now, each client is going to have a banker. Now, they can have multiple bankers, and bankers can have multiple clients. So we need somehow to store the banker information, but also the relationships. So over here we have, again, a client, and a client can have a banker, and then a banker can have a client, but also we can have another client over here. Let's say we have another client, and they can also be associated with this banker. And we can also have another client over here, and then maybe we have another banker, and then this client is associated with this banker as well as this banker. And then maybe this banker is associated, of course, with this client as well as this client. And then it's getting a little bit messy, but then over here, then this client would be associated with this banker. It's getting a little messy, but this is a many-to-many relationship, and we have to somehow figure out how we can do that with TypeORM. Now, also, of course, a client can have transactions, and they can have many transactions, but a transaction is going to fall only to one client. So this is a many-to-one or one-to-many relationship. And this is very common SQL knowledge. I do expect you to have a little bit of SQL knowledge if you're taking this TypeORM crash course, or even MongoDB knowledge, and I'll understand how we can relate data together. So that is pretty much it, and this is what we're going to be building with TypeORM. Now, if you weren't using any sort of ORM, typically you would have to create a bunch of the SQL statements. So something like create table client, and then you would add all of the columns and their data types, and then for any relationship you would have to create your own foreign key, and then you would have to specify that it's a foreign key, and then for anything like subsequent, if you want to perform a query or a mutation, you would have to do something like select star from client where ID is 1. If you want to get a data where there's a relationship, you would have to perform some sort of join. It gets really, really complicated, and in a real application, you almost never want to take this route. You never want to just write raw SQL. So instead, what you want to do is you want to rely on an ORM to do all these things for you. So TypeORM, what it does is it really simplifies the way that we create tables in our database, and it also really simplifies the way that we can query or mutate our data. So for example, over here, instead of doing something like select star from client where ID is equal to 1, you can just do client.find1, and then we provide the ID. Now this is very simple, but we can have something very complicated where we have a lot of different conditions, or we have an inner join. So the SQL statement can get relatively complicated, but this statement, it might get a little more complicated, but not as much. So that's why we ultimately want to use some sort of ORM. Alright, so that is introducing TypeORM to you. In the next video, we're just going to do a little bit of setup. Hey everybody, for this section, we are going to set up our environment that we need to continue on with this crash course. And luckily, we don't really need much. All we really need is a database running on our local machine. And as I said, the database of our choosing is going to be Postgres. Now, thankfully, Postgres is a relatively easy download. So what you can do is you can go to postgres.org and /download, and then download whatever Postgres version you need for whatever operating system you're using. For instance, I am using a Mac. So what I suggest if you are using Mac, well, click on Mac, of course. And then I suggest downloading the Postgres app. So just go to Postgres app. You could also use Homebrew if you want to, but I suggest going to the Postgres app and downloading this over here. And what this is going to give you is a nice GUI, kind of like this. If you go over here, you should be able to see it. And what this does is it allows us to run a Postgres server on our local machine. And if we go to server settings, you can see that it's running on port 5432. Apologies if this is small, don't worry, we're not going to be working with this as much. I just can't really zoom in with this interface. Now, what this does is it provides us with a server, a Postgres server on our local machine. But we need a way to actually visualize our data. And to visualize our data, we can use another handy tool known as Postico. This is a free tool. There is a paid version that gives us a little bit of extra features, such as like filtering our data. But really, we can just get the free version. So just go ahead and download that. And once you download that, you should be able to open up an interface. It looks relatively similar to this, but now you should be able to click on your databases and see the tables. So you can see here, I have a bunch of tables in our database. I went ahead and I created a TypeORM database using the Postico interface. To do that, just go ahead and right click on Postico and just say new database and call it whatever it is that you want. I'm just going to go ahead and delete this database because I don't need that database, but I created a TypeORM database where we're going to be storing all of our Postgres data. Okay, so that is pretty much all you need. Other than that, you will need VS Code or another text editor because we are going to be working with, coding out our application. So you're going to need some sort of text editor, preferably VS Code. In this section, we are going to be talking about connections. Now, what do I mean by that? Well, TypeORM needs to connect to our database in order for it to do all the things that we want it to do, create tables, query elements, as well as update or delete elements. Now, how do we do that? Well, we have to provide some credentials to TypeORM telling it, hey, we want you to connect to this particular database. And that is what we are going to be doing in this section. So remember, the database that we have created is a Postgres database that is running on our local machine. Now, if you go to the Postgres app and you go to server setting, you can see that over here, again, very, very small, but you can see some of the credentials. So you can see that the username is my username, which is Laith Harb, as well as the port is 5432. I don't have a password for this database. So let's go ahead and let's connect to that database using TypeORM. Now to do that, we first need to initialize a node application. So let's just open up our text editor. I'm using VS Code for this, and I opened up a brand new empty directory. And all I am going to do is just npm init-y inside of the integrated terminal. And what this is going to do is it's going to create the package.json for us. Now, another thing that we need to do is create a tsconfig.json file. So let's do that, tsconfig.json, because we are going to be working with, well, TypeScript for this, because TypeScript is pretty much used with TypeORM. You can use it with JavaScript, but most of the time if you're using TypeORM, you're using it in conjunction with TypeScript. So let's go ahead over here. We're going to create this file, and this file is going to house a bunch of rules that is going to apply to our TypeScript application. Now, for the purpose of this crash course, I'm just going to copy the rules that I have inside of my own TypeORM crash course directory. Private at the moment, but will be public later. So you can go ahead and just go over here to this URL. I'll have the description I'll have the link in the description below, and just copy this and just paste it in there. Really all you have to do. And now what we need to do is install a few dependencies. So I'm going to install some dependencies and explain exactly why we need each one. The first thing is we need to create an application, a REST application. TypeORM is an ORM. It doesn't create a REST API for us. So we need some sort of framework that allows us to create a Node REST application. The simplest one and the most popular is Express. So that is what we're going to be using. Now, because we're doing it with TypeScript, we need some of the types associated with Express. So we're also going to download @types-express. And then we're going to need a few more downloads. In order to interact with a Postgres database, we need to install PG. So that is another dependency that we need. We also need tsnode, which allows us to run our TypeScript application in development. And then let's also install TypeORM, which is the ORM that we are learning about. And lastly, we're going to install TypeScript because we're using TypeScript. All right. So that is pretty much it. So let's do all these installations. And my cat is trying to get in. So if you hear some ruckus, that's my cat. Okay, so we installed this. And now what I want to do is I want to create a start script. And I'm going to call this dev for development. So we can run npm run dev in order to run our application. So ultimately what we want to do is we want to run index.ts. And we want to do that inside of a source directory. So the source directory is going to house our application. So let's create an index.ts file. And for now, let's just console.log hello. So I'm going to console.log hello. And then in here, what we can do is say, hey, we want to run our application. Now, the thing is we need to, what I prefer is that we run our application, and when we make a change to our application, we don't have to rerun it. To do that, I highly suggest installing nodemon globally on our machine. I already did this, but if you didn't, then go ahead and execute this command. It's a great command to utilize in order to hot reload our project and not have to rerun our server every single time. So once you globally install it, what you can do is nodemon --watch, and then we're going to say that, hey, we want you to watch all of the files that are inside of any directory that contain a .ts appendage right over here. So we want you to watch for all of this. And then once you watch for this, and if something ever changes, we want you to execute tsnode. And then we want you to execute tsnode in the source.index.ts file. So let's just quickly try this out. So now what we can do is we can do npm run dev, and this should work, and we should see the console hello, and which is great. And then this is because this is a TS file. Typically things won't work if we don't use tsnode. Now if I were to add some exclamation marks, you can see that the server restarts and we see those logs. Okay, terrific. So that works as expected. All right, so that is pretty much all we really need to do to set up our project. Now let's just create the connection. So inside of the index.ts file, let's create a main function. So this is going to be the function that we are going to run in order to execute our project. So we're going to run this function ultimately. And in here, what I want to do is I want to connect to Postgres. So let's go ahead and let's do that. Now, in order to connect to Postgres with TypeORM, we're going to need to import some methods. So from TypeORM, what we are going to import is something called create connection. Very descriptive. Pretty much tells us exactly what we need to do. Now, in here, what we can do is, well, create the connection. So what we can do is we can do something like const connection is equal to await, and this is going to be asynchronous. Creating this connection is going to be asynchronous, so that's why we're utilizing async await here. And we can say create connection. And now what we can do is you can say some of the descriptions that we need. So if we hover over this, you can, I guess you can't. I'll tell you exactly what we need. We need to describe the database that we are utilizing. So we first have to describe the type, and this is the type of database that we can utilize or that we are utilizing. So over here you can see we have MariaDB, MongoDB, MySQL, native, Postgres is the one that we're utilizing. And then we have to provide it with the host. If we're using some sort of production database or a database inside of AWS or Microsoft Azure, we have to provide the URLs from there. But here we're just using localhost. So this is localhost. And then we have to provide the port. The port for a Postgres database is typically 5432. And then we have to provide the username, and you can get this by going to the Postgres app and looking at the server settings. And I'm going to say that, well, I'm not going to say, the username for here is Latharb. And then I'm going to provide the password. We don't have a password, so here what we can say is our password is undefined. And then we also have to lastly define the database. Remember, we created a TypeORM database in Postico. And so what we can do now is just say that we want to utilize the TypeORM database. Very simple stuff. All right, so now that right there is going to create the connection. So you can see here that, well, nothing happened. And that is actually good, because if something failed and if the connection didn't happen, then what ends up happening is create connection throws an error. And to show you this, I can just say, let me provide some invalid credentials. Let's just get rid of the B. And if I were to save this, you can see here that it throws an error. And that happens when we can't connect to our database. But if we were to connect properly, we'd get no error and everything seems fine. Now, one thing is I really like some sort of validation saying that, hey, I did connect to the database. And if it didn't, I don't want it to throw an error. I just want it to tell me, hey, I was unable to connect to the DB. So what we can do instead is put this in a try-catch block. So let's put this in a try-catch block, and let's get rid of this variable connection. We'll just await this for now, and we'll say if we pass this, then what I want to do is I want to say console.log and connected to Postgres. So we have connected successfully to Postgres. And then if something happened, if some error occurred, then we can either throw an error. I'm just going to say console.error, and I'm going to say unable to connect to Postgres. So if I were to save this, we should see connected to Postgres. If I provide some sort of invalid credentials, you should see unable to connect to Postgres. And of course, if we want, we can also throw an error. Typically, we would want to throw an error. So you know what? Let's just go ahead and do that. Let's just say throw new error. And we're going to say here that the error is, let's actually go ahead and just log the error itself for this. So we're going to log the error, and over here we're going to say unable to connect to DB. So again, if I provide invalid credentials, then I get a bunch of errors, which is good. So this is descriptive errors for me. But now I can realize that, hey, I provided invalid credentials, and now I'm able to connect to the DB. So that's pretty much it. Very, very simple. Connecting to your database is very easy. Now, right now we're using localhost, so this is completely fine the way that we're doing things. But if we are actually wanting to connect to a real production database, this is the way that we did things is not really the best way. And the reason for this is because these strings are pretty much in plain sight. Anybody can utilize these strings if we want them. If they get access to this file, anybody can connect to our database. Now, nobody can connect to this database particularly because, well, it's running on our local machine. But again, if we have a database in AWS, then anybody can connect to it if they have these credentials. So what I highly, highly suggest is store these in environment variables. And the reason why this is a great approach is, for one, of course, it hides all of these things and therefore nobody can see them. But also, sometimes we have different environments and we might want to use different databases for those environments. For example, maybe we have a staging environment. We want to have a database for staging. We don't want to use production database for staging. So we might want to do that. I won't do it in this section because this is a crash course about TypeORM and not really utilizing environment variables. But if you want to, I highly suggest taking the environment variable approach because that's typically how things are done. In this section, we are going to be talking about entities. What do I mean by entities? Well, right now, let's go to our Postico database right over here, or our Postgres database using the Postico tool. And if I were to open this, you can see that there are no tables. So typically, again, the way that we create tables is with create table and then the name of the table commands, SQL commands. But again, we want to do that with an ORM, notably in this case, TypeORM. So to do that, we have to define entities inside of TypeORM. So in TypeORM, tables are basically entities, is what we call them. So we can define our entities, and then TypeORM is going to create those tables with those specific columns that we have specified. So inside of our source directory, typically what is done is we create an entities directory. And in here, we're going to have all of our entities that are going to correspond to tables inside of our database. So let's go ahead and let's create a client entity. So to do that, we're going to create a client.ts file. So in here, we're going to create the entity that again is going to correspond to a client table inside of our database. All right, so let's go about doing that right now. So of course, we're going to need to import some things from TypeORM. Now, the first thing that we need to import is entity. So this is a decorator that defines that what we want to do is create an entity. So to create an entity, what we typically do is we create a class and we export to this class. So we do class client, and then we want to go ahead and create this class right over here. But of course, what we have to do is also define that this class is an entity, and that is where we use the entity decorator. So over here, we can say at entity, and then we can invoke it like a decorator. So this is the decorator. So we do it right above. And then inside of this decorator, we can also specify the name of the table that we want. So over here, I want it to be called lowercase client. Now, another thing that is very important is we need to extend the base entity. So over here, we can also get base entity. And then we can extend the base entity over here. And why is that very important? Well, because this allows us to perform all of the CRUD operations that is necessary. And actually, for now, I'll leave it on, but I'll show you once we want to perform these CRUD operations, I'll get rid of it and show you why it's pretty much impossible to do it without base entity. But for now, just take my word for it, we need to extend base entity. Okay, cool. So in here, we're going to define all of the columns and their associated data type. So the first thing is, let's say we want the name of the client. So let's say that we want the first name. So over here, we can say first name, and then we can say that the first name is a string. Similarly, we can do last name, and we can say the last name is a string. And this is great. This works fine, but we also have to specify that these are columns. So to do that, we can just take the column decorator. So the column decorator, and then in here, we can say at column, and then over here, similarly, we can say at column. And this specifies that, hey, this is a column. All right, cool. So that is really all that we need to do. And now what we can do is we can also say that, hey, at column, we also want to specify another column, and we want this column to be an email. And the type here is just the typical TypeScript types. So over here, let's say we also want the email to be unique. So inside of the decorator, the column decorator, we can provide an object and have multiple different options. So over here, we can say unique, and then we can say unique is equal to true. So we can also specify that if we want to. Now let's go ahead and let's create, well, our clients need to have a card number. So let's say column, and then we're gonna say card number, and then we're gonna say string. And then over here, let's say that the card number also has to be unique. And let's say that the length of the card is always 10. So the length of the card has to be 10. So we can also provide that. And this, what it does is just creates constraints inside of our database, like unique constraints. And over here, it does some sort of check constraint to check that the length is equal to 10. So of course we can add multiple columns within here. It doesn't also always have to be a string. We can also provide a number. So, well, a client is gonna have a balance. So this is how much money they have inside of their bank account. So we can say balance, and we can say this is type number. Now the thing is this is going to be by default type integer. Now, when we have something like, when we're dealing with something like money, we probably want to use another type known as numeric. So to define the type, we can also over here, instead of simply relying on the TypeScript type, what we can do is simply just say type, and then we can define whatever type that we want to use. In this case, I want to use numeric. So we can also do that as well. Let's also create another type where the type is a Boolean. So let's just say at column, and let's say that we're gonna have, let's say, an is active column, and this is a Boolean. Now let's say that when we create this user, we always want to assume that this is active. So what we can do here is, well, what we can do is we can provide a default. So we can provide a default. So we can say that, hey, by default, it's always true. So if we don't provide this, in the database, it's always going to be true. Now, another thing we can do is we can also change the name of the column. So over here, the name of the column is always going to be this name over here. But if we want to, for some reason, have a different name inside of our class versus the name inside of the database, we can just provide the name, and we can say, hey, we want this to be called active. Okay, cool. Now we can do many things as well. Let's say here we can also have multiple different types. We can say something like column, and we can say maybe we have some additional information. Okay, so we have additional info. So additional info, and let's say that this type is an object. So we can also have a type of object where, let's say we need to know their age, which is a number, and for some reason we also want their hair color, let's say. Hair color, I don't know why a bank would need that, which is a string. So over here, what we can also do is say that, hey, this is going to be of type simple JSON. So simple JSON. And what we can also do is say, if you don't provide this information, that's completely fine. So we can say that this is nullable. So we don't have to provide this information. So we can say nullable true. By default, I believe it's nullable false. So we need to define nullable true. But if we don't define it, I believe it's nullable false. So we actually have to provide it. All right, so let's look at a few more types. So another type, let's look at simple array, for instance. So let's say we want to provide an array of things. So for instance, maybe we want to know all of the family members, their names, and this is just an array of strings. Well, over here, simply, we can just define the type of simple array. And then that's pretty much it. And we can also, if we want to, even default this to an empty array if we don't want to provide it. All right, so that is pretty much it. That's pretty much how you can create your table inside of your database. Now, how do we end up migrating this data inside of our database? Well, we have to first tell TypeORM about it, because right now it's just in a random file. So now all we really have to do is import this, because remember we exported it. So we can import client from, we can say /entities, and then inside of the create connection, we can also specify an array of all the entities that we are utilizing. In this case, we're utilizing the client entity. So I went ahead and saved this, and I got an error. So what is this error? So you can see here, entity client does not have a primary column. And the thing is we always want some sort of primary ID with our database. So we need to create a column that houses a primary ID. So to do this, we need to create, well, an ID. And an ID typically has maybe an auto increment, a unique constraint, and things of that nature. So what we could do is we could do that manually ourselves, but in TypeORM, we can also use the primary column decorator. So instead of just a normal decorator, we can say that, hey, this is a primary column. And what this does is it creates a bunch of the constraints that are needed for a primary column, and it makes that a primary key. So we can say here that this is an ID, and then we can specify that this is a number. We can also say that if we want that this is a string and it is of type of UUID. So you can also do that as well, and it will automatically generate UUIDs, but I'm just going to say number. And so over here is just going to auto increment and make this a primary key. All right, so that is pretty much it. And if I were to save this now, it has connected to Postgres. Okay, cool. So this seems fine. But now if we go to Postico and if we refresh, you can see I still don't have that table. And that's because we need to perform a migration. And instead of migrations, what I like to do, because this is so much easier, is go to create connection. And in here, I'm just going to say, I want you to synchronize everything. So if we were to save this, it's just going to synchronize all of the entities that we have specified over here. So now if we were to refresh, you can see that we have our client table. I hope this, I really can't make this any bigger. I truly apologize. Maybe in the next section, I'll figure out a way to make this a little bit bigger. Let's see if there's any like zoom in. Seems like zoom is gone here. I'll hopefully I can try to make it bigger, but you can take my word for it that we have created a table where we have an ID, first name, last name, email, card number, balance, active, additional info, and family member. So we have created these entities, and hopefully you can see it on your end as well. Now, the last thing I want to talk about is some of the other entities or other decorators that we can utilize. So, for example, we may want to have a created at or an updated at column. So how do we do that? Well, all we really have to do is use some of these special decorators. So we have a create date column, and we also have a update date column. And then in here, all we have to do is just say, hey, we want to use this decorator, and we want this to be a created at, and this is of type date. Now, what this thing is going to do is it's going to, well, every single time we create a record, it's going to, well, append the date to this column as well. So it's going to automatically, by default, create it to date.now. So this is what's really cool about these decorators. And there's a lot of little decorators that we can utilize. And we're going to look at them throughout the crash course. So we can also use update date column. And then over here, we can say updated at is the column name, and then it's of type date. All right, so if we were to save this and to refresh our database, remember, because we synchronized it, we should see those columns over here. And you're going to see in action that, we never have to specify these. These will automatically insert. All right, so that is the basics of entities. I hope that makes sense. I'll also try my best to figure out a way to zoom this, and if I can't, really apologize. In the next section, we're going to talk about inheritance. In this section, we are going to be talking about inheritance. And to explain what it is, let's just go through an example. So now let's say that we want to create another table and thus another entity for the bankers, because, well, we have clients and we also have bankers. So let's go ahead inside of our entities directory and let's just create a banker.ts file. Very simple. And let's just go ahead and just copy everything over here and let's just paste it in there. And let's just get rid of some of the things that we don't want. So the banker is going to have an ID as well as a first name, last name, email, and the banker is also going to have a card number. However, we're not going to store the banker's a balance as well. If we don't really want to store is active because they're always active because they're employees. We also don't care about their family, nor do we care about this additional information. Okay, cool. So over here, really, we're using a lot of the same columns that we have here inside of our client. Now, let's also add another column, and this column is going to be a number, and this is just going to be the employee number. So the employee number. And let's go ahead and let's just add some constraints if we want to here as well. So we're going to have a unique constraint. We're going to set that equal to true. And we are also going to have a, let's say, a length of 10. Okay, so this is cool. This is terrific. Let's just change this to banker over here. And similarly, let's change this to banker. And now what we can do is we can go to the index and we can also say banker over here. Notice that it actually auto imported. So we can save this, and because we have synchronized to true, it seemed like something failed here actually. Entity banker does not support length. Oh, yes, of course. And that's because this length doesn't work if it's a number, it has to be a string. So we're gonna say string for this. So you can save this. And now if we go over here to Postico, we go to our database, we see we have a banker and a client. Now the only thing is, this is kind of really repetitive. And the reason for this is we're using a lot of these same columns between client and banker. For instance, we have the primary column, as well as we have the first name, last name, email, and card number. Over here we have first name, last name, email, and card number. Now the only difference over here is we have employee number, which we don't have in the client, and then over here we have in the client we have the balance and the is active and additional information and family members, which is not located in the banker. But there's a lot of duplication. So how can we fix this duplication? Well, we can fix this duplication with inheritance. And we kind of looked at inheritance a little bit with this over here, because over here we're inheriting a lot of the properties associated with, or all of the properties associated with base entity. And I know we haven't looked into what base entity is, but we inherited those properties. So what we can also do is inherit all the properties from a separate class that we have created. For instance, what we can do here is inside of the entities directory, let's create a utils directory. I guess this isn't really a util, but let's just over here, let's create a person.ts file. And again, let's go ahead and let's just copy all of this over here. And over here, we can create a person entity. So this person entity, we're never really going to save it in our database, so really no need to have that in there. And we can say that this person entity extends the base entity. And we can say that the person entity has the ID, the first name, last name, email, and card number. But then everything else it doesn't really have. So let's get rid of all of these other things over here. So these are basically the columns that it has in common between the client and the banker. All right, so now that we have saved that, what we can do now is we can get rid of all of these columns that are redundant. So we can get rid of them and instead extend person. So that way we get all of the columns that are associated with this person class as well as the base entity. So we're extending that over here. So we're extending person, and that way we don't have to have all this redundant stuff. So if I were to save this, you can see that it actually still works completely fine. And now similarly, we can do over here in the banker, we can get rid of all of this. And we could only have just the unique stuff to the banker. And instead here, extend person, notice it auto imported and it's saved. And now if we want to add, we can also get rid of like base entity if we want to, or primary column because we're not using that anymore. Similarly, we can do that in the client, get rid of base entity as well as this over here. But now, let's say we need to create another column that is for both client and banker. Maybe we also want their maiden or we want their middle name. We could just add that simply over here. We could just say middle name and we can save that, connect to our database. And now if we go to banker, we should see, again, very small, but at the very end over here, we should see middle name. Similarly, if we go to client, we also don't see the middle name. Let me quickly refresh this. Okay, we do see the middle name over here. Okay, so that is terrific, and that is inheritance, which reduces duplication. Let me just quickly remove the middle name because we don't really want that, and that should remove it from both the client and the banker. In this section, we are going to be talking about relationships. So how do we relate data together? For example, so far we have created the client as well as the banker. And we have said that, hey, for this, we're going to have a many-to-many relationship. For instance, many clients can have many bankers, and then many bankers can also have many clients. Also, we also want to create a relationship between a client and their transactions. So one client can have many transactions, but any one transaction will have just one client. Now let's just begin with the one-to-many and many-to-one relationship, because that's a lot easier to work with, and then we'll move on to the many-to-many relationships. So let's go ahead and let's create the transaction entity. So we'll say transaction.ts, and we're going to create this entity. All right, so let's go about doing that right now. So the first thing that we're going to need to do is just a bunch of imports from TypeORM. So let's go here, TypeORM, and we're going to, of course, need something like base entity, the column, and then we're also going to need entity. So all these, the basic things. And then over here, we're going to use the entity decorator. We're going to call this transactions. Very, very simple. And then we're going to export a class called transactions. And then we're going to extend the base entity. Very, very simple stuff. And then over here, let's just create a very simple table. The first thing we need is the primary column. So let's just use the primary column decorator. Actually, the thing is primary column, we're going to have to generate the primary column. So what I suggest doing instead is using primary generate column. So if we go here, primary generated column, this automatically generates it for us. And the same will hold true over here. So let's just use primary generated column. And similarly over here, we'll just say generated. Okay, cool. And we do not need the create and update columns for this section. So we can save that. And then over here, we can say that over here, we have an ID, and we'll say that this is a number. Now there's some syntactical errors here, and that's because this is extends, not extend. And let's just quickly create the rest of this. So let's just say over here, we want a column for the transaction type. So whether it's a deposit or a withdraw. So over here, we can say that this is a string. But you know what? I want to also say that I want to limit the string. So it can either be a deposit or withdraw. So what we can do is we can just create an enum, which is supported in TypeScript. And we can say transaction types, and then we can say that we have deposit, and deposit equals the string deposit. And then also we have withdraw that equals the string withdraw. So very, very easy. So now how do we use this enum? Well, very easily. All we have to do is just specify the type. And we can say that this is a enum type, and then we have to specify the enum by saying, well, enum, and then saying that transaction type. Now we have an error here because, well, I need a quote or a comma. And the last thing is the amount. So over here, let's just do column. We're gonna say of type numeric because we're dealing with numbers here. So type numeric, and then let's go over here and let's just say this is the amount and it is of type number. Okay, so that is pretty much it. We can also have the created at and updated at if we want to. For now, I think that is fine. So let's go ahead and save this, and let's go to here and let's just import this. Really, we can just import it by saying transaction. Trying to this one right here, transaction. We called it transaction. I prefer to not have it plural. So over here we can say transaction. Similarly here we can say transaction. And now if I managed to zoom it in a little bit, but the column names are not zoomed in, unfortunately. But if I were to refresh this, we should see a transaction table with ID, type, and amount. Okay, cool. So now what we want to do is we want to relate many transactions to a user. How do we do that? Well, typically when we want to do a one-to-many or many-to-one relationship, the entity that is the, I guess, the many side of that one-to-many. So, for instance, in this case, it would be the transactions, because we have many transactions that can belong to a client. That entity is the thing that houses a foreign key, which maps to the primary key of the other entity that is the one part of the one-to-many relationship. So for here, we would have if we were to create a transaction, we would have some sort of client ID, and it would link to the primary ID of the client that this transaction belongs to. So how do we do that in TypeORM? Well, we don't have to go ahead and create a ID and then link it together. All we really have to do is specify the relationships, and everything else will be done for us. So how do we do that? Well, in the transactions, so what we can do is we can say that, hey, this transactions entity has a many-to-one relationship. So we can actually import that from here, many-to-one relationship. So we imported it from TypeORM. And then here what we can say is, so the first thing that we're going to do is say that, hey, what is this ultimately going to return? Well, this is going to be a function that returns clients. Now we're going to have to import the clients. So over here, if you can just do import client from the client. So you can see here that it's going to import the client. And then the second parameter is going to be another function, but this time we're going to have all of the clients, and then we want to return the client.transactions. Now this might not make a lot of sense to you. Do not worry. The reason why this is failing is because we also have to do the same thing with the client as well. But for now, this is fine. Now, another thing we can also specify is a join column, because ultimately we're going to want to create a join. And because this is the many-to-one, we're going to go over here and specify a join. And we're going to say that the name of the primary ID is client ID. And then over here, lastly, all we're going to have to do is say that this is going to be a client, and it is of type client. So over here, we're specifying the relationship. This is a many-to-one relationship. Over here with the @join column decorator that I auto imported from here, we're specifying the name of the primary key. And then over here, we're specifying just the ultimate column, essentially. So what we can do at this point is say transactions.client, and we should be able to get our client. Now the reason why this is failing is because we also have to do the exact same thing for the client section. So over here, let's go here, and then here we're going to have to do a one-to-many relationship. So here we can say one-to-many. Again, I auto imported it, but you can import it manually if you want. And then we're going to do pretty much the same thing here. So the first thing we're going to have is a function that says that we are going to return transaction. So, and this is this transaction from the entities right over here. Again, auto imported it. And then we're going to say that what we ultimately want to do is we want to get the transaction, and then from the transaction we want to return transaction.client. So that is specifying the relationship. And then over here we don't really have to have a join column because you don't have a foreign key for this one. Remember, the foreign key is usually on the many side, not on the one side. So over here we can just say transactions, and then we can say transactions is going to be a transaction, but this is an array of transactions. And you can see now that it's completely fine because we actually have a client here. So when we return client from a transaction, that's fine. Over here we have transactions. So when we return transactions from a client, that's okay. So if I were to save this, everything should be fine. And notice again that we didn't directly create a column with client ID, but at the end of the day, if I go to the transactions and I were to refresh, you can see here that we have the client ID. So right there, we have specified a many-to-one relationship and or a one-to-many relationship. All right, so that is all we have to do. We'll talk about how we can insert data a little bit later. But now let's talk about many-to-many relationships. So remember that in a many-to-many relationship, a banker can have many clients as well as a client can have many bankers. So how are we going to specify all of this? Well, we're going to do that with, well, as you can imagine, a many-to-many decorator. So inside of the client, let's just create this right now. So let's go, actually, you know what? Let's move on to the banker. We haven't worked with the banker a lot. So what we're going to do is we're going to create a many-to-many relationship. So over here, let's specify the many-to-many decorator. And here, all we have to do is specify a function that returns, well, the type. And we ultimately want to return the client. And so let's actually auto import the client as well. So over here, you can see that we auto imported the client. And this is going to return, well, multiple clients. So it's going to return multiple clients, so an array of clients. But over here, we can also specify a join table to specify the overall. So, okay, I think I should probably mention exactly how many-to-many relationships work. So because we have a many-to-many relationship, we can't have just some foreign key in an actual entity. We actually have to create a separate table. So we're going to have to create a separate table, and all that table is going to contain two columns. The first column is going to be the ID of the banker, and then the second column is going to be the ID of a client. And those two columns are going to link those two entities together. For instance, if we had, let's say, 5 clients with ID 1, 2, 3, 4, 5, and then 5 bankers with ID 1, 2, 3, 4, 5, and we wanted to link the client with ID 1 to the bankers with ID 1, 2, 3, then we would have in a separate table, we would have ID 1 for the client, and then ID 2 for the banker, ID 1 for the client, ID 3 for the banker, ID 1 for the client, and then ID 3 for the banker. I'm not sure if I kind of messed that up, but let me just say it. So let's say over here we have, again, 5 clients with ID 1, 2, 3, 4, 5, and then similarly with the bankers. So over here we can have something like client ID, and then over here we can have banker ID. And so over here we might have 1, and then over here we might have 3. Over here we can have 1 again. So you can see here that the same exact client has 2 different bankers. But then we can also have something like client 3 is also working with banker 3. And that is how we perform many-to-many relationships. So we need a separate table. So to do that, we're going to have to define at least on one of the many-to-many entity or decorators over here, because we're going to have to specify a many-to-many relationship here, but we only have to do this once. We have to define a join table. So over here, we're going to say that the name of this table is going to be bankers and then clients. And then we're going to specify the join columns. Remember, we've done this before. So the first column, we can call it banker or banker ID. I'll just call it banker. And this is going to reference, the ID of the banker. So it's going to reference the ID of the banker. Now, similarly, we're going to have to now create the inverse join column. So this is on the other side. And so this is defining, again, this is defining the join column of the banker. The inverse join column is just going to define all the other things for the client. So the inverse join column. Then over here, we're going to say client, and we're going to say for client, this references the ID, so the primary key. So if I were to save this, everything should probably fail because we have, actually, I guess it didn't fail, but now what we can do is go over here to the client and then specify the many-to-many relationship in the client. So over here, we can just do similarly at many-to-many. And over here, we can also say that this is a function that returns banker type. Let's actually go ahead and auto import the bankers. Now what we can basically do is say bankers and then banker, an array of bankers. You have to specify the join column because we already did that over here. Now what's great is if I go back to our database, you see that I get this table where I have a banker column and a client column. If you can't see it, take my word for it. But so far, that's really all we have to do. We can also specify one-to-one relationships that work very similarly to the one-to-many relationships using the one-to-one decorator. But yeah, that's how we set up relationships. But that is pretty much it really for how we create tables. There's a few more things that I'll talk about. But now we're going to start talking about exactly how to interact with our tables, like inserting data, querying for data, etc. In this section, we are going to be learning about creating data, which is basically adding a record inside of our database, just a fancy term for that. So let's go about doing that with TypeORM. Now to do it, we have to first configure a few things. We have to create our Express application because again, TypeORM does not build our REST API. We need some framework, or we can use plain vanilla Node. I prefer to use Express. So we need to configure our Express application first. So let's do that right now. So inside of our index.js, let's just import Express from Express. So we'll do import Express from Express. If you don't know Express, really easy. Honestly, if you know any REST API, I feel like you should be able to follow along. So over here we have our Express, and really all we have to do here is a few things. So once we connect to our database, we want to connect to our Express application and get it up and running. So we do that inside of this try block. So we can do app.listen. We can listen on port 880. And then over here, we can have a callback and we say console.log now running on port 880. So, okay, so that's good, but you might be wondering, okay, well, app is not defined, which makes sense. I actually forgot to do this. You also have to create your Express app. So we do app is equal to Express. So now we have created our Express application. That's really almost all we have to do. So if we save this, we should see now running on port 880. Another thing that we need to do is add the Express middleware, and we add in the middleware with the .use. And over here, we're just going to use the Express JSON middleware. And what this does is it allows us to parse the body of any request that we made. Okay, cool. So that's it. That's really all we have to do to configure our Express application. Let's go to the source directory and we're going to create our routes. So let's create a routes directory. And to begin with, let's create a route that allows us to create our clients. So over here, we're just going to say create underscore clients, of course. That's our client. We're going to create just one client at a time. So we're going to have that in here. And in here, we're going to do some little bit of Express setup to create this route. So we're going to do import Express from Express. And then we're also going to do const router. This allows us to just create a very easy route and that we can later export. So we can do express dot router. Again, it just allows us to create a route. If this doesn't make sense to you, don't worry. Really, all you have to know is that now we can do router.post to make a post request. And we can also export this router. So let's export this router. And we can say we want to export the router as, and we're going to rename it to create client router. And now inside of the inside of this post, we're going to need a few things. We're going to need the path, which is going to be API/client. So we're going to make a post request to API/client. Then we are going to hit this callback and perform some action. This is of course the request and the response. So we're going to hit some action. Now to actually utilize this, let's actually just do a res.send of hello, and let's just make this a get request for now. Actually, no, we'll leave it as a post request. And to actually utilize this inside of our index.js, we have to utilize middleware. So now what we can do is we can say app.use, and we want to use this. So we can say create, create client. Hopefully I can auto import it. Yes, I can. I auto imported it from here, so we can save that, create client router. That's all we have to do, and now we have configured our API. So if we go to, let's say, Postman, let's open that up. This isn't anything TypeORM specific, really. This is just setting up an API. Hopefully that made sense. I kind of just went really fast with it. I do expect you to have at least, maybe not Express knowledge, but knowledge of an API. So I do expect you to know what like post requests are, and hopefully you can understand the syntax. So if I were to make this request, right now I have some stuff in the body, that's okay. But if I were to make this request, and let's go here, you can see that I'm making a request to localhost 880, which we have up and running, /API/client, and it's a post request. And if I were to make this request, we should see hello, and we do. Okay, cool. So that works. So now what we want to do is we eventually want to give you, or inside the request, have this data inside of the body. So the first name, the last name, the email, the card number, and the balance. And we want to eventually save that data inside of our database. So we should see that data. If I go to TypeORM and then I go to the client, I should see that right over here. So how do we do that? Well, we're going to be able to do that through this right here. So through this class. And the reason why we'll be able to do it through this class is because we extended person, and person extended base entity. And so what we can do is we can perform many operations on that class because we extended base entity. So what we can do is we can do a create operation, update operation, save operation, whatever it is. So over here, what we can do is, first of all, let's just get all of the data from the body. So we can do that by destructuring out the first name, the last name, the email, the card number, as well as the balance from the rec.body. And then what we can do is import the client. So let's go ahead and let's import that client from the client entity. So that's going to be in the client entity. You can import the client. And now again, because we extended base entity, we can do a lot of different things. We could do like client.count, .create, .delete, .find. You can do a bunch of different methods. And now let me just show you, if we didn't have base entity, so if we didn't import that, then we wouldn't have those methods. So you can see here, all those methods are gone. And that's the reason why we have base entity. So let's just save that. And so now we can do client dot, let's say, create. So we're going to go ahead and we're going to create something. Now, when we execute this, it doesn't actually save it in the database. What it does is it really is just constructs that object for us. And I'll show you how we can save it a little bit later. But what we can do is we can do something like const client is equal to client.create. And this is going to take in an object with all of the parameters that match the ones inside of the entity. So we can see here we want to have the first name be the first name from the body, the last name as well be the last name from the body, the email, the card number, which will be the card number from the body, and then the balance. So this is really all we need. So now what we can do is save this to the database. So now what we can do is we can just say await, and maybe we probably want to async this because this is going to be asynchronous. This right here is not asynchronous because all we're doing is just creating an object. Now we can do await, and then we can say client that we created dot save, and that saves it to the database. And then what we can also do is return that client that we have created. And that's really all we have to do to create data. So if I were to execute this request with, I went to the body and I changed it to JSON format, and I have over here the first name, the last name, email, card number. Remember the card number has to be 10 in length, and we also have a balance of 0 starting off. So if I were to make this request, you can see I get back my data, and I actually also get back additional data like the ID is active, family member. Remember we have those as defaults, as well as this one. It creates this for us on the spot. But now if we go to our database and we were to refresh, we can see our data. So we see here ID of 1, Al, Tedo, we have the email, and we have a bunch of other things. Cool. So yeah, that was really, really easy. I highly encourage you guys to do it for the banker as well. Because what we eventually want to do is we want to also learn how to perform it ourselves. So if you want, you can pause the video, but if not, I'll just create the banker route as well, just for practice. And this is going to be very similar, if not the same. Really, all we're changing is some of these things as well, because over here maybe you have the employee number, whereas for the client we don't. So what I'm going to do is I'm just going to quickly copy and paste this, and I'm going to create a banker route. So create banker.ts file, and then in here we're going to change this. We're going to do a little bit of changing. So we're going to do API. Over here this is going to be banker. Over here this is going to be banker. And over here we're gonna do banker. Might as well change this also to banker, and we'll say banker here. Now the data is gonna be a little bit different, not much different really. Instead of balance, we're gonna have employee number, and then here instead of balance we're gonna have employee number, which is going to be employee number, and over here we're just going to save, or we're going to return back the banker. That's it. Very, very easy. Also, let's change this as well. So let's just say create banker route. So inside of the index.js, very easily now we could just use app.use, and then we can have create banker router. It didn't auto import, now it did. Okay, cool. That's really all we have to do. So now if I were to make this request, so if I go to my body, I have Sally, Bartita, and then we have the email, the number, as well as the employee number. If I were to make this request, it completely fails. I wonder why that is. So null value in column balances violates not null constraint. I actually wonder why in the world does the banker have a balance? It does have a balance, which is very strange. It shouldn't even have a balance. So either I mistakenly added it here, which I did. I did mistakenly add it in the persons and then inherited it. Let me see if it has it in here, because it should have the balance on its own in here, and it does. Okay, so I just mistakenly added it there. So now what we can do, if I were to refresh this, you can see it's gone. And if I were to make this request again, you can see that, again, if I refresh, you can see that we have our data. All right, so that is creating data. Now, in the next few sections, we're going to learn about how we can perform all of the other CRUD operations, as well as how we can relate data. We talked about how we can form relationships in a table level with foreign keys mapping to primary keys, but how do we do that when we want to insert data? Well, TypeORM makes that extremely easy. And to go through with this, we're going to go through two examples, forming a relationship between a client as well as a banker, but we're also going to form a relationship between a transaction and a client. So let's begin with the transaction client, because that's a lot easier, because at that point we're only dealing with a many-to-one relationship. So in here, let's create another route, and we're going to call this the create transaction route. So let's go here, and we're gonna say create transaction.ts, and then in here we're just gonna do the usual. Let's just do it from scratch. We're gonna import express from express. We're also gonna import. We're gonna import transaction from, not from TypeORM, but from the entities, and then from transaction. Okay, cool. And then now what we're gonna do is just gonna create our route with router. So we're gonna call this router, and we're gonna do express.router. This is just very simple stuff. Okay, cool. Why is that giving us, events? No, from Express, please. Okay, so now let's create a post request, because we're creating a transaction. And we'll just call this /API. And then remember, we have to link the transaction to a client. So we need to have the client's ID coming from somewhere. Or some sort of information that will allow us to identify the client. In this case, really the only reliable thing is the client ID. So we can actually get that from the params. So we can do something like /client, and then we can do :client ID. And this is going to correspond to the parameters. So now what we can do is something like, when we make this request, it'll be /API/client/1. And this will be the client ID over here. And let's also specify that this is going to be transaction. So we'll say /transaction. Let's make this asynchronous, because we're going to be using a lot of asynchronicity. Okay, so this is really all we have to do. So now what we can do is let's extract the client ID from the clients, or from the params, from the rec.params. And to create the transaction, of course, we're going to need the amount that we're going to be doing, as well as the type. So whether it's a deposit or a withdraw. So we can do that through getting the type and the amount through the rec.body. Very, very simple. So the first thing that we need to do is get this ID and actually make sure that that ID belongs to a client. And if it does belong to a client, then we want to get that client back. So we'll talk about how we can fetch data a little bit later in the lecture, but for now I'll show you how to do it. So we can do something like const client, and then we can import the client entity. So we can import that entity, so the client entity. And so what we can do is something like await and then client dot, and then we have here find. So we have a bunch of find methods. Find gets an array. Find and count, well, you can probably assume what that does. It gets this array and it counts how many there are. Over here, this find by IDs, find one or fail, so that throws an error. But what we want to do is just find one. So we want to find one, and we're going to provide the ID. In this case, the ID is the client ID. Now the client ID is going to be a string, so we're going to have to parse it into an integer. So we can do that very easily with parse int. All right, so that is pretty much it. Now, if we don't get our client, what ends up happening is it returns null. So what we can do is we can say, hey, if the client doesn't exist, we can do something like return res.json, and we can return the message saying, custom message saying client not found. Very, very simple and very easy. So now let's go ahead and let's create the transaction. So, okay, we have a client. That client does exist because we passed this if block. So now we want to create the transaction, but we also want to link the transaction to the client. Well, we can do that by, let's create the transaction. So we'll say const transaction is equal to, and we don't have to await this because we're not actually saving it to the database. We can say dot create, and then over here, the first thing that we have to do is specify, of course, the amount as well as the client. And then you might be thinking, okay, well, the client ID, then I just specify the client ID as client ID, but that's not how it works here, because in the transaction entity, we have no column called the client ID, even though in the database we do have a client ID, but we do have a client, and that is supposed to be the whole client. So all we really have to do is just pass in this whole client. So what we can do here instead is just say client. We want to pass in the client. And what this will do is we'll get that client's ID and save that ID in the client ID column. So all that it really does is just create it. Now we have to actually save it inside of our database. So now we can just do transaction.save. We can also await this. Now, one thing that I want to do is if we decide to deposit money or withdraw money, I want to actually change the balance of the client. So let's go about doing that right now. So we can say something like if the type, remember the type is the thing that we passed in, triple equals, and remember the type can either be deposit or withdraw because we specified the enum. Let's actually get the transaction types from here. We can say if the transaction type is equal to deposit, then what we want to do is we want to get the client, and what we want to do is we want to get their balance as well. And then we want to change we want to make the client's balance equal to whatever the client's balance is plus the amount. And similarly, we can do an else if. And then over here, what we can do is if the type is equal to the transaction type dot withdraw, we can do the client balance is equal to the client balance minus the amount. Very, very simple stuff. So now all we have to do is actually save that. So we can do something like client, if I can spell client correctly, client.save. And then maybe if everything is successful, we can just return the new client. Or maybe we can just return a message, because over here we have a message. So might as well just be consistent, return a message saying transaction added or something like that. Or we could just return the transaction. Honestly, whatever it is that you want. So the last thing that we have to do, of course, is just export that router. So we'll export it as create. So create a transaction router. So that's all we really have to do, pretty much it. Okay. So now what we can do is go to our index.ts file. And then inside of our index.ts file, this is going to be called and this is from the create transaction. So it's going to be called the create transaction router. We're also going to do an app.use and then create transaction router. Very, very simple stuff. If we were to save this, everything is working perfectly. So now if I were to make this request, so let's say over here we want to create the transaction. So let's actually deposit first. Let's actually give ourselves some money. So we want to deposit, and the client is going to be client 1. So localhost API, client 1, transaction. So at the end of the day, what we should get is inside of, let's actually go to the client. So the client, their balance should be 500, which I believe was the amount. Remember, client ID of 1, so 500. And then we should also create a transaction, which we don't have thus far, but the client ID here should be 1. So hopefully this works. I really hope this works. It's supposed to work. If it doesn't work, then I made an error. So if I were to make this request, it doesn't work. Darn it. What is the problem? Invalid input value for enum deposit. So apparently this value is wrong. So let's go to our create transaction, or actually let's go to our transaction entity. And I misspelled deposit. That was the problem. So let's save that. Apologies for that. So now if I were to make this request again, it has worked. So we have transaction added. Now, how do we truly test if it works? Well, let's go to our transactions. And if you refresh, you can see here that we have a transaction. It's a deposit out of 500, and it corresponds to the user with ID of 1. And then if we go to TypeORM and then we go to our client, we should see their balance now at 500. All right, cool. So that is terrific. So now what we want to do is we want to also somehow create the connection between the banker and the client. So let's create a route for this. So let's go over here to our routes. And then we're going to call this route, I wonder what we should call this route. Let's just call it connect banker to client. So let's go here and let's say connect banker to client.ts. All right, very simple. Honestly, let's get rid of all these files. They're kind of getting messy. But what I'm gonna do is I'm just gonna copy some things here. I'm gonna do a little copy and pasting just for just so I can get the setup done. It kind of takes a long time to set up. So we don't need this. We are eventually going to need to import the client as well as the banker. So let's just get that out of the way. So from entities, we want to get the banker as well. Okay, so that is cool. Let's just get rid of everything here, everything inside of the route. We're going to make this a put request because we're really just updating things. And we're going to call this, what are we going to call this? Yeah, let's just call it connect banker to client. Now, really, all we want to do here is get a banker, get their ID, and then get a client, get their ID, and just place it in here. So if we want to connect Sally with Ted, then we would have an ID of 2 for the banker and then ID of 1 for the client. Very, very simple. So let's go about doing that. Now the first thing is we need to, of course, get the client and with the banker. So we can say to get the banker, we'll just use the banker ID in the params. So we will want to say that, hey, we want to use this ID for the banker. And then for the client, we want to use the client ID. All right, very, very easy. So now what we can do is let's just get those IDs. So we'll do rect.params, and we'll do banker ID, client ID. So the first thing, of course, that we have to do is we have to get our client and our banker. So what we'll do is we'll get our client just to see if they exist, of course. So we can say something like find one, and then we're gonna use parse int and parse int of the client. Then we can say banker is equal to await the banker dot find one, parse int, and then we can say the banker ID. So here we're gonna get the banker. I'm gonna do a quick shortcut and just check if both are available. So we can do something like if the banker and the client exist, then what we can do is if they both exist, then we want to do logic, of course. But if they don't exist, you know what? Actually, let's just say if they don't exist. So if they both don't exist, what we want to do is we want to return res.json, and then we're gonna do we'll do a message saying banker or client not found. Very simple message. So if they both do exist, then what we want to do is we want to connect them together. Now, how do we connect them together? Well, very easily. Let's go back to the banker entity. Let's get rid of all these other ones. And let's just go back to the banker entity. Remember, the banker entity has this column called clients, and that is going to be an array of clients. So very easily, really, all we have to do is get the banker dot clients, not card number, dot clients, and then, or this should be or, not and, sorry. So we're going to get the banker dot clients, and then all we're going to do is we're going to say that, hey, this is going to be equal to an array of, well, the client that we have specified. Now, the best thing to do is probably say that, hey, this is going to be an array of all of the clients that already exist, plus this client that we have created. So plus this client that we have created right over here. Very, very simple. And you might be thinking, okay, well, we can also do it the other way around. We can do something like client.bankers is equal to an array. We can't really do that, even though that does work. We can only do this kind of connection with the entity that has the @join table. So you can have it for both if you want, but I just put it for the banker. At the end of the day, it's going to do the same thing. So now what we want to do is, well, very simply, just go ahead and just await. So we can do a banker.save, and then we'll just return something here. So we'll say banker connected to client. So we can save that, and that's pretty much it. So now all we have to do is just import this inside of our index.js file. So we can do from routes / connect whatever to banker. You can use middleware here, app.use, use that. So now what we want to do is let's actually connect someone. So we should see some data over here. So we have a banker, Sally, of 2, and then we have a client with an ID of 1. So let's go ahead and let's make this request. And so this is going to be connect banker to client. So we have this request. The banker has an ID of 2. The client has an ID of 1. If we were to make this request, it fails, of course. Something always has to go wrong. It says here, oh, okay. So let's, so let's just get rid of this. Yeah, this doesn't work. So let's do that. And if I were to make this request again, now the banker is connected to our clients. Okay, so nothing really changes here. So nothing changes. But the only thing that changes is inside of this table, we have this connection. So that's really all we have to do. And that's how we can connect data together. And the same thing works with a one-to-one relationship. Really, if you understand this concept, you'll understand how to do it with one-to-ones. Cool. In this section, we're going to learn about deleting data. Now, there's a lot of things that we could possibly delete in this crash course. We can delete a client, a banker, or a transaction. Realistically, we should be able to do all of them, but for the sake of this crash course, I'm just going to delete the client. And some problems are going to arise. They're going to be consistent throughout if you want to delete a banker or a transaction. And we're going to solve those problems in this section. So let's go ahead and let's create a route responsible for deleting clients. So let's go over here and we're going to call this route, well, delete client. So we're going to delete one client. Let's do it from scratch as well. It's kind of annoying doing everything from scratch, but it is what it is. So we'll just import Express from Express. We're going to use the client from the entity, so I might as well also import that. So let's go here. By the way, if you're wondering why we can use import without setting up Babel, it's because we're using TypeScript, and TypeScript can compile it down to regular JavaScript. You might be more used to require, which is pretty much the same thing. But I like this syntactically a lot better. Okay, so let's just create the router. So we're gonna do is equal to the router. And then let's do router, and this time it's gonna be a router.delete. And this is gonna be /API. We wanna delete the client. And we also have to say which client we wanna delete, so we'll provide the client ID. This is gonna be asynchronous, so might as well right now just make it async await. And so to do this, well, it's really easy. So first of all, let's just get the client. We're gonna get the client ID, and then we're gonna do a rec.param. So we're gonna get the client ID from the rec.param, and very easily, what we can do now is simply just do client.delete. And then we can provide the primary key, which is the client ID. So we can just parse int this, and then we can provide that ID. Very easy. And then over here, what we could do is maybe even get the response and just return the response. That's it. Seems super easy. All right, now let's actually just export this out. So we'll export router as delete client router. And now what we can do in here is just do app.use delete client router. Notice I auto imported it. And let's just make this request. So what we want to do is we want to delete client 1. Very easy. If I were to send this off, it's going to fail. And the reason why it fails, as you can see here, update or delete on table, what it does is it's going to violate some foreign key constraints on the transaction. And the reason for this is because if we delete the client, so if we end up deleting this client, the client with ID 1 will not exist. However, over here in the transaction, we're saying that this transaction belongs to the client with the ID of 1. And so, well, this is not right because this is a foreign key. Similarly, this is also going to fail. This is also going to cause some failure because these are also foreign keys. So how do we fix this? Well, the best thing, in my opinion, and actually, scratch that. This really depends on your application and what you ultimately want to do. Maybe you want to keep the transactions, and what you want to do is you want to just change the client ID to null. Or what you want to do is if you delete the client, you also want to delete all of their transactions, as well as the banker client relationship in this table. That is what we are going to do, and that is known as a cascade. So when we want to delete something, we're going to cascade the deletes to all of the relationships. So to do that, we very easily, all we really have to do is go to the entities and define cascades. So for example, in the transaction, so in the transaction entity, we're going to say over here, in the many-to-one relationship, we're also going to provide an object. And we're going to say, hey, when we delete a client, we want it to, again, we can do multiple things. We can set the ID to null. Or we can restrict it, saying, hey, we can't do that. Or we can perform no action, or we can perform just the default action, which is this, or we can just cascade the delete. In this case, I'm just going to cascade the delete. Now, this is great. This is really going to solve a lot of our issues. However, we're still going to run into some issues. And the reason for this is because, well, we didn't cascade the deletion of this as well. So if we were to make this request again, oh, I guess it did work, surprisingly. Oh, this also deleted. I guess by default it does. I thought it would. Okay, so I guess by default this actually deletes as well. But now you can also notice that our transaction has been deleted. Cool. Just to quickly note, I thought that what we had to do for a many-to-many relationship is go to the many-to-many relationship, and similarly here, also provide an object. This is just going to be cascade equal to true. In the many-to-many relationship, this is the syntax for it. But I guess by default it is true. Whereas if we provide false, I think we would have gotten that error. So what we'll do, just to quickly test this out, is let's actually do the exact same thing for the client entity. So let's go ahead and let's do that exact same thing. So let's go here, let's get the client, and then in the many-to-many relationship, let's also provide that cascade of false. So over here, we'll say cascade of false. Okay. So now let's first create that relationship. So let's make this request. And it says here that the client is not found. That makes sense. So let's create the client. This client has an ID of 2. So let's go here. Let's create the connection. And now let's try to delete the client. So if I were to make this request, it's still, I'm very I'm honestly surprised. So I guess the cascades are not really working. That's how it is in the documentation, but I guess that's how it works. So I'm a little surprised by that. But what I'm gonna do is I'm gonna leave it as true. I'm gonna leave this as true. So I guess by default, or always, this is always going to cascade. But when we do a one-to-many, we always have to provide the onDelete cascade. Okay, cool. So that is pretty much it. And I'll see you guys in the next section where we're going to learn about getting data. So finally, fetching data. In this last section, we're going to be learning about how we can query for data. So we've learned about how we can add data. We also learned a little bit about how we can update data as well as delete data, but we haven't talked about how we can query data. So let's get into it. Now there's a few things that we can query. We can query the banker, the transactions, the clients. We're going to be querying the clients, but It's a little bit more tricky than just, having a dot find and finding all the clients. For one, because sometimes we want to selectively pick what we want. We don't want to query for everything. For example, over here, I already ran the request. Let's actually go over here. You can see we have the first name, the last name, the email. Sometimes when we're querying, we may not want this additional information. We may not want the family member for that specific route. So we want to selectively pick what we want. We also want to filter for what we want. So maybe we want to filter for, hey, if the first name is equal to this, or if the balance is greater than 8 or something like that. So we may want to do that as well. So that is another filter option that we can do. And lastly, we may want to show the clients and their associated transactions. So over here, remember the transactions is in a completely separate table. So we're going to have to somehow get that information and show it for that specific client. So querying is more complicated than the other ones usually, and because of that, we're gonna have to use a different approach that we have been using thus far. So far we've been using kind of the built-in methods, the find one methods, the delete methods, and all these things. But for querying, we're gonna use something else. So let's just create the route right now. So I'm gonna say fetch clients. We're not creating anything. Fetch clients.ts, and let's just go ahead and let's just do a const. I always forget we're using TypeScript, so we can use import. So we can import express from express, and then over here we can do const app is equal to express, and then we can do well, we're not doing app. What am I doing here? We want the router, because we just have a router. We don't want to create a brand new Express application. So we'll do router. And this is a get request. So we'll just say /get. And it will have the route be /API/bankers. And then we're going to have async rec res. Just change that. This is just a callback, and there we go. We should have our router. Might as well, let's just export it. So we'll export router as let's say fetch client router. Okay, cool. So that's really all we need. But now let's go ahead and let's start querying for our clients. So let's just use the traditional route of querying. So far we've been doing something like we've been getting the client entity, which I can't seem to auto import, so I'll just import it myself. So let's import the client entity. We will not be using this actually for this section. So we're just gonna get that client. And then we usually do something like const client is equal to await, and then we can await, we'll do client.find to find them all, and we want to just find them all with no condition, so we're just going to leave it like empty. And then ultimately we could just do a return res.json, and we can return that client. So if we were to go over here, let's just do an app.use, and we can say fetch client router, fetch client router. Let's import that. Fetch client router. Why is that not in here? It's in the directory, which is kind of strange. It's not autofilling. Fetch clients.ts. Import fetch client router is not. I'm very surprised by this because it is in the. It's in that directory. see why that is. Or maybe because I'm not running the application. Could be that. Let's just do npm run dev. Let's see if cannot find name fetch C. Did you mean fetch? app.use fetch C. And oh, that's what it is. Okay. So let's just copy that in here and let's paste that in there. So that should fix it. I'm not sure why I'm still getting this weird syntax highlighting. So let's see is here an import path cannot be found for fetch clients.ts. So let's just get rid of the TS maybe. There we go. Okay. So if we, okay, cool. All right. So I really didn't want to pause the video there. So hopefully you guys appreciate the debugging. So let's just go ahead and let's make this request. And I called this bankers. Apologies. Let's just change that to clients. So let's just change it to clients. It's not bankers. So let's go here and I also let's rename this as well to get clients. And let's go ahead and make this request to API/clients. And if I were to make this request, you can see here that, well, I get all of the data. And you know what? Let's actually go ahead and let's create more clients. So let's create, first of all, let's create a bunch of new transactions. So let's do maybe, let's see how many transactions I have right now for that particular client. So let's just do a refresh. It seems as though we have this many transactions, as well as we have our client. You know what? This is good enough. We'll just rely on that one person. So we have this one individual over here, which is terrific. This is cool. But there's a little bit of a problem at the moment. So if I were to make this request again, if I were to make this request again, you can see here that we have the ID, the first name, but we may want to, selectively pick what we want. Similarly, we may want to filter. Similarly, we may want to get the transactions associated with that individual. So how do we go about doing that? Well, it's really hard to do it with this built-in method, because this built-in method doesn't allow us to do joins. It doesn't allow us to do complex filters. It doesn't really allow us to selectively pick what we want. So instead, what we're going to rely on is the create query builder from TypeORM. And what this allows us to do is really just make SQL statements. It makes basically getting the data similar to how you would just write a SQL statement. And that's why it's really important to understand SQL if you are trying to learn any type of ORM. So let's go ahead here and let's just use this. And so to use this, what we would do is something like this. We would do, okay, const clients is equal to await create query builder. And then over here, we're going to specify what table we want to use. So over here, we're going to say, hey, we want to use the banker table. So, or rather, sorry, the client table, not the banker table. And then over here, we just append certain methods like we are utilizing a SQL statements. So we're going to say, hey, we want to select, and if we want to select everything, we just say client. But if we want to select specific things, then we would do something like client underscore first name, or client underscore, and then if we want to select something else, we can do client dot last name underscore last name. So we can do that, but for now, let's just query for everything. And then, okay, so where are we querying from? Well, we will say we're querying from client, and we're also going to alias this as client. And then, if we want to have any conditions, like, where clause, so we can have that in there, and we can say client.id, and then is equal to, a variable ID. So we can say here is equal to the variable ID, and we can get this variable ID from either the rec body or the rec param. And so to specify a variableness, you just do colon and then whatever that variable name is. And then inside of an object as the second parameter, then you would specify the value of that variable. So I'm just going to hard code it in, but you can get this variable again from either the body or the param itself. And then lastly, we can use get one or get many. So we can just specify, hey, that this is, we want to get just one. So now if I were to save this, well, I guess we're just getting one client, so we can save that. And let's just wait for the request to go. If I were to make this request, it works perfectly fine. But now again, we can have we can have more complexity. Again, we can also select whatever it is that we want. So if we just want the first name, we can select that. So you can see here that I just get the first name. If that's really what I want, I can also get multiple things if I want to. And I would do that by adding another select. So I can say add select. And this basically specifies that, hey, I want to add another thing that I want to select. And I can say, hey, I want to select client.lastname. And so if I were to make this request, just get rid of that comma, apologies. And if I were to go here, you can see that I get both the client last name as well as the first name. I can always change this to balance if I want to. Let's just quickly try that out. So you can see here that I also get the balance. And you can also add multiple more complicated selects. So maybe what you could do is you can add something like this. So maybe add a select. So if you maybe did a join, you could do something like, hey, I want the sum. So really just if you have knowledge of SQL, then this really is just SQL in just an object-oriented fashion. So you can say, oh, I want maybe the sum of the transactions if you did some sort of join. So I want the sum of the transactions, and I want this to be called sum or something like that. And you can also add a group by. So you can also have a group by to group by the client ID and things of that nature. Okay, cool. So we won't do that because it's just a little bit more complicated. But really, if you understand SQL, you should be able to figure that out. All right, so let's just talk about this over here. This right here is a where clause, but we could always have multiple where clauses. So we can have something like, let's just get many. And so if I were to save this right now, I'm just getting an array of all the clients where the client ID is equal to 3. So if I were to make this request, you can see here that, well, we get an array of one person. Maybe we want to get an array of all the clients that are very, very rich. So maybe they have a net worth over 500,000. So we can do something like client.balance. And then over here, this can be balance instead. And then we can say that the balance is 500,000. And we would want to do here greater than or equal to 500,000. So in that case, if we were to make this request, we should just get an empty array. If we were to make this less than 500,000, then we're going to make this request. We do get that. We can also have obviously things that are more complicated. We can also have the and. So we can say and. So maybe we can say over here balance minimum or minimum balance. So we want maybe like people in between. So we want people that are greater than, that have more money or equal to maybe 400,000, and the client is less than or equal to the max balance. Over here we can specify the min balance, and then over here the max balance, let's just say balance is let's say 600,000. Okay, cool. So if we were to save this, hopefully I made no syntactical error. So over here, the client balance has to be greater than 450,000, but less than 600,000. So we should get this individual right over here, and we do. If I were to decrease the max balance to 450,000, remember this is 400 and almost 500,000. And if I were to save this, we won't get anything. And really, again, this is just simple SQL. So we can add whatever condition that we want in here. All right, so the last thing that I want to do is, what if we also want to see the transactions? Well, to do that, we're going to have to perform a join. So we're going to perform the join right over here after the from. And over here, we're just going to perform a left join. We can also perform a right join, or we can perform an inner join. Now, I'm just going to perform a left join. And what I'm going to do is I'm also going to perform the join and select the stuff so I can end up seeing it. So here, what this does is it performs the join, but it doesn't select it if we don't put and select. I think it's easy just to say, hey, and select. So we want to also select it. And then inside of the join, we're going to specify, okay, well, we want the transactions, and we're going to call this transactions. All right, so over here, we're saying that we want to get the client transactions. And what's great about this is that it's smart enough to figure out, we don't have to specify any of the IDs or anything. What it does is it automatically is smart enough to say, hey, we want the client transactions. So what it's going to do is just going to look at the foreign keys and then map them together. And then over here, we're just calling them transactions. So we can change this name to whatever it is that we want. We can call it cats, for instance. That's just going to be what the JSON blob is going to be called. So let's just save that. And if I were to make this request, I have to fix this. So let's make this 500,000. Make this request. You can see here that we get the first name, last name, as well as the transactions. Okay, and this is going to be an array of transactions, of course, that match this particular individual. All right, cool. And that is pretty much it. I hope you guys learned a lot of TypeORM, and I'll see you guys in the next one.